Well, now we're still on section 10.2. We're doing question 41, and we have to find the sum of the series. So in its present form, we can't do much with that, but if we rewrite this as two fractions using partial fractions, then we'll be able to deal with it. So I've started the partial fraction operation. Now let's multiply through by the LCD, which is the product of these two, and if we multiply through by that product, we just get a 4 here. And if we multiply each term by that product, what we'll have is an A times 4n plus 1 plus B times 4n minus 3. Multiplying that out, we get 4an plus A plus 4bn minus 3b. Now gathering up like terms, and these two are like terms, we'll get 4a plus 4b, and factoring out an n, there it is, plus, and the constant term is made up of a minus 3b, so I'll just put parentheses around that to reinforce the idea that is the constant term. Now, there is no term containing n over here, so this coefficient must be 0, which implies that 4a must equal negative 4b, or dividing through by 4, a equals negative b. Now, setting this constant term equal to the constant 4, and replacing a with negative b, we have negative 4b equals 4, so b must equal, if we divide through by negative 4, b must equal negative 1. Well, if b equals negative 1, then a must be equal to negative times a negative 1, so a equals 1. Well, we've got that part of it done. Now that we have our identities for a and b, we can go ahead and rebuild what we have here in two terms, in the form of two terms, and go ahead and evaluate. And if we let n equal 1, we'll get 1. If we let n equal 1 here, we'll get a minus 1/5. Plus, if we let n equal 2 here, we'll get 1/5. If we let n equal 2 here, we'll get minus 1/9. Excuse me, 1/9. If we let n be 3, we'll get plus 1/9. And letting n be 3, we'll get minus 1/13. Let n be 4, we'll get plus 1/13 minus 1/17, and so on, plus plus, and we'll wind up with a minus, since the previous term will add out, 1/4k plus 1. And notice how these terms continue to add out. We've got a telescoping series here. And so the limit as k goes to infinity for this term is 0. So ultimately, this thing converges to 1, and we're done.